Welcome to Go Get It. Today we will see one of the very basic and important topic from computer networks, that is IP addresses. From exam point of view, you can find a lot of numericals based on this topic, and trust me, this is really very easy for to grasp. This complete topic is divided into two video sessions. This session is dedicated to IP addresses and their classification. In our next session, we will learn about something called subnetting in computer networks. It is assumed that you are aware of certain concepts, say binary notation, decimal notation, various network layer devices, say switches, routers, etc., and packet in computer networks. Now let's see the need of IP address in computer networks. From the figure on the screen, you can make out that there are two different networks with different IP addresses. So here this is one network with certain systems with IP, and this is another computer network which has certain different set of systems which are connected with the help of some devices which are called as switch, router, etc. Now let's say, for example, this network whose address is 10.0.0.0 and this computer in this network whose IP or the label assigned to this IP or this computer 10.60.212.3 wants to communicate with a computer or a system which is present in entirely a different network whose IP address is 170.90.1.3. We will shortly see the definition of IP address. But before that, just let me explain the need of IP in computer networks. For the timing, you can assume an IP address is a label given to any computer in a communication network which follows IP or the internet protocol. Now let's see, this computer wants to communicate or want to send a packet to this computer which is present in an entirely different network. Now as soon as it realizes that the packet or the system whose the recipient's IP address does not belongs to its own network, with the help of ARP it will determine the router's MAC address and it will send the packet to the router A. Router A, with the help of forwarding table, it realizes that this packet does not belongs to this network whose interface connected to router A. It will determine the router B's address, or for example you can consider that it has determined the router B's address for the further communication and it has forwarded the packet to router B. Similarly, router B determines that this packet does not belongs to its interface and it forwards the packet to router D with the help of forwarding table. And again in router D it realizes that the packet or the recipient belongs to its own network, and hence with the help of ARP it will determine the MAC address of the recipient and it will forward the packet to the destined or the recipient's computer system, and this is how it is got consumed by the destined or the recipient computer system. This is how IP address plays very important role in computer networks. Now what is IP address? IP address is nothing but internet protocol address, which is a numerical or a label or a name assigned to a device, say a computer or a printer, which is a part of any network that uses internet protocol for communication. IP addresses are very useful in identifying a specific host in a network. These are the 32-bit addresses or the numbers which are divided into 4 octets. Each octet represents 8-bit binary number. So as I said, 4 octets, 1 octet contains 8 bits. So below is an example of an IP address. This example, you can see the notation used here, which is also called as dotted notation. Here you can see that these are the binary numbers which are separated by dots. So these binary numbers are machine readable, like computer can understand very easily this dotted notation which is in the form of binary numbers. And for human readability, we can convert this binary number into their specific decimal notation. So in all, we can make out that 172.16.254.1 is an IP address. IP address uniquely identifies a computer in any network. This is a unique label or a unique name given to any system in a network. Basically, IP addresses are divided into two parts. First part is network ID and second part is host ID, and this consolidates to IP addresses. Before we proceed to classification of IP address, there is one more thing I want to discuss here, that there are two different versions of IP nowadays. Initially, it was released with IPv4, that is version 4. Whatever we are seeing belongs to IPv4, and there is one more version released in 1995, that is IPv6 version 6. So the only difference here is like before we see the difference here, the IPv4 was not able to cope up with the requirement of IP addresses assigned to the computers, and that's how IPv6 came into picture. So IPv4 addresses or IPv4 address are of 32-bit, and whereas in IPv6 these are of 128 bits. We'll concentrate on IPv4 here. So classification of IP addresses. Again, one more thing I want to clear here, that there are the IP addressing system has been divided into two parts. One is classful addressing and another is classless addressing. So what is classful addressing? So classful addressing here is like various IP addresses have been divided into various classes from class A to class E. Now you can see here that class A has 4 octets, 1, 2, 3 and 4, out of which the very first bit of first octet is always fixed in case of class A, which is denoted by 0, and rest of the 7 bits belongs to network ID, and the rest of the 24 bits belongs to host ID. I hope 24 bits makes like 8 plus 8 plus 8 makes 24 bits. Similarly, next classification is class B. In class B, we have 2 octets belongs to NID and the rest of the 2 blocks belongs to host ID. Out of these 2 blocks, we have 1 0, that is the first 2 bits are fixed, and rest of the 14 bits belongs to NID and 16 bits for host ID. Next classification is class C. Again, similarly, here the first 3 bits are fixed and 3 octets belongs to network ID, and that's how 21 bits plus 3, 24 bits belongs to NID, and rest of the 8 bits belongs to host ID. Likewise, we have class D and E also. So class D has first 4 bits and class E again has first 4 bits with a difference of 0 and 1. So class D are basically used for multicast addressing, and class E are the reserved for special addresses, or some special cases these class E addresses are used. Now let's see in detail the class A classification. So as I said, for class A the very first bit is fixed and rest of the 7 bits belongs to the network ID. Now as I said, this is 7 bits. Now this 7 bits can lead to 2 raised to 7 network addresses. Now 2 raised to 7 gives you total 128. Please don't mind my writing, I'm using a mouse here so I'm not pretty comfortable. So total we get 128. Now in class A, only 126 addresses are used for network address. Now as we have total 128 network addresses possible in class A, how come 126 came into picture? Now you can see here that 0.0.0 is again one of the possible combination which leads to a class A IP address, and 127.255.255.255. So 0 to 127, as I said, network ID. So the very first address, this one, and the very last address, this one, these are the 2 special IP addresses. This special IP address 0.0.0.0 is this network. I mean, whatever communication wants to you want to communicate within the network, then this IP address of 0.0.0 is used, which is reserved or which is called a special IP address. And again, the next set is 127.255.255.255. 255.255.255, or frankly speaking 127.0.0.0 from to 127.255.255.255. This belongs to special IP address, which is also called as loopback address. Loopback addresses we will see in our next session, what are loopback address or some other set of special IP addresses. So that's how you can ignore the first two IP addresses, which are special IP addresses, and that's how we get 126 network addresses. Again, the all zeros and all ones in network ID are dedicated for special IP address. So you can notice here that if 7 bits are 1, that makes 127, and 255.255.255, all ones in host ID are special IP addresses. So total number of IP addresses in class A can be represented as follows. So as I said, we have total here 2 raised to 24 host addresses. So we have total 2 raised to 24 possible IP addresses. Okay, so out of this 2 raised to 24, the special IP address we can ignore, so minus 2. So total host IPs are 2 raised to 24 minus 2, such a huge number. Now there are certain level of questions generally asked in the examination, like these are some obvious questions generally they ask in objective questions. How many total number of host addresses in class A? Now you can see that 126 into 2 raised to 24 minus 2. How come this figure comes? So 126 is nothing but the number of networks in class A multiplied by 2 raised to 24 minus 2 host IPs. So this will give you the total number of host IP addresses in class A. Second question comes generally is total number of special addresses in class A. Now this is somewhat tricky, and I'll take one more slide for this. So the equation comes to equation derives to be is 2 into 126 plus 2 into 2 raised to 24. Now let's see how this equation derives. As I told, class A starts from 0.0.0 to 127.255.255.255. That is the very except the first bit of first octet, that is 0. Rest all the bits are 1. So that makes 127.255.255.255. Now you can see that 0.0.0.0 to 0.255.255.255. This complete set, this complete block of address belongs to special IP addresses. Similarly, as I told, from 127.0 to 127.255.255 belongs to again a special IP address case. That's how we got 2 raised to 2 into 2 raised to 24, and rest of the IP addresses are 2 into 126. So 53.0.0 is a network address again, and 53.255.255.255 again is a special address. So usable address are, for example, we are considering it as an example that 53 is nothing but the network address. So for the IP addresses which are usable or used to assign to some computer from class A classification are 53.0.0.1 to 53.255.255.254. Similarly, we will have 53, 54, 55 likewise from 1 to 126.255.255.254. That will be the complete set of usable IP addresses. So we have 2 into 126 plus 2 into 2 raised to 24 special addresses in class A, such a vestige of IP addresses in class A. So that's why class A addressing system is not used in organization where the requirement is very low, like in thousands or lakhs, because it leads to some millions of IP addresses. Next classification is class B. Similarly, class B, as we discussed earlier, that the first 2 bits are reserved or fixed, and in class B we don't have any special network address. all are usable addresses. But here the situation of 128.0.0.0 and the last one 191.255.255.255, these are the special IP addresses. So total we have 2 raised to like 16 bits meant for host IDs. So 2 raised to 16 minus 2 are the host IPs. You can see that for every address this first 2 bits are always fixed. Similarly in class C, the first 3 bits are fixed 110. Again here from 192.0.0.0 special IP address, and similarly this IP address, the very last IP address of this classification, is again a special IP address, and as only 8 bits belongs to this host IP, we have 2 raised to 8 minus 2 host IPs in case of class C classification. So total class C networks we have 2 raised to 21 because these 3 bits are fixed always, and total IP addresses are 2 raised to 21 multiplied by 2 raised to 8 minus 2. Now let's see some tip. So this tip is basically used to determine like if in examination you have been given an IP address and you have to determine this IP address belongs to which class. Sometimes students or the candidates fails to understand immediately. So this tip will prove to be very helpful for you, I hope. So you can have like the very first octet, which is of 8 bits. So 2 raised to 8 gives you 256. So 256 you can divide into 2. That gives you 128 to 128. Again, this 128 is divided into 64. It is like 50-50%. Again 64 is divided into 32 is again going to divide into 16 and 16. So how to determine which IP address belongs to which class? So for class A, you can see if it belongs to the very first octet or the very first decimal number, if it ranges within 0 to 127, that is 128 numbers within this range, then it belongs to class A. Similarly, you can add 64 to 127, so you will get the next classification. Say for example 128 to 191. Whatever IP address, the first octet of the IP address belongs to this range, that means it belongs to class B. For class C again 192 or 191 plus 32. So you can notice that this 0 plus 128 gives you 127. So this range has been derived from 0 plus 128, this complete number. Again 127 plus 64, again you will get the next range, that is 128 to 191. 191 plus 32, that gives you the next range, 192 to 223. Again 223 plus 16, that gives you 239, and 239 plus 16, the rest of the 16 bits, gives you 240 to 255. That's how you can determine easily that the given IP address belongs to which class. Again, one more tip. This tip is generally they ask numerical questions based on this tip. This tip can be very I felt very useful. So you can consider that there are 2 computer systems with IP addresses mentioned on their screen, which are connected via certain routers, R1 router and R2. Now we have something called default mask, default subnet mask, or network mask. For class A we have 255.0.0.0, class B gives 255.255.0.0, and class C 255.255.255.0. Now what is this default mask or default subnet mask? This mask is generally used to determine the network address of the recipient's network address. So how does it help the routers to determine the network address? So let's say this this computer system wants to communicate with this computer system. So it will start sending a packet via R1. It will go to router. Now as soon as it comes to this router, for example, it will do a calculation. So just notice the calculation here. Here this is nothing but the recipient's IP address, 200.150.169.73. It is same as this. and again it will AND with, so as I told in the previous slide or previous screen, that you can determine which class it belongs to. So it's not difficult for router to determine which class it belongs to. It can you can notice that 200 belongs to class C, so it will AND, it's nothing but logical AND with 255.255.255.0, which is the default subnet mask or default network mask of class C addressing. So this complete ANDing, logical ANDing of these two numbers gives you a result 200.150.169.0. So this IP address is nothing but the network address of the intended network or the intended system. That's how router determines that this network it belongs to, and its job is done. It will send the packet to this specific network via R2, and that's how it is consumed in this computer system. So that's how default subnet mask helps in determining the network address of the recipient's network. So that's all in this session. Thanks for listening. Subscribe for more videos. Thank you.